Welcome student. Let's start with Algebra 2. This course will make math come alive with its many intriguing examples of algebra in the world around you. Right from the baseball to the theater lightning to the space exploration. In Algebra 2, we are going to cover many topics like solving equations and inequalities, graphs and functions, polynomials, power and roots, complex numbers, quadratic equations, matrices, and sequence and series. And today we are going to start with one of its very important topic, quadratic equation. Let's see the definition of a quadratic equation. A quadratic equation is a polynomial equation of the second degree with its general form, or you can say standard form, ax squared plus bx plus c equals to 0, where x is the variable with the highest power 2 and a, b, c are the constant. So that means ax squared plus bx plus c equals to 0 is a quadratic equation. Now let's move to the next. Here we are going to learn about one of the important points of a quadratic equation. We know that the general form of a quadratic equation is ax squared plus bx plus c equals to 0, where a, b and c are the constant. And remember, this a should never be equals to 0, because if a equals to 0, then term ax squared will become 0 and we will be left only with a linear equation, not a quadratic equation. See few examples of quadratic equation. Look at the very first example, x squared plus 4x minus 9 equals to 0. Here the variable is x with the highest power 2. So that means it's a quadratic equation. Now let's see the second example, that is 2y squared plus 5y equals to 9. Here the variable is y with the highest power 2. So that means it is also a quadratic equation. Similarly, you can see x squared minus 7 equals to 0 is also a quadratic equation. Now let's differentiate this quadratic equation from a non-quadratic equation. Let's see a few examples of non-quadratic equations also. We have x cubed plus 5x squared plus 2x minus 9 equals to 0. Here the variable is x, but the highest power here is 3, not 2. So that means it's not a quadratic equation. Let's see the second example. It says 3z raised to power 4 minus 2z equals to 1. Here the variable is z with the highest power 4, not 2. So that means it's not a quadratic equation. Similarly, we have third example, p raised to power 5 plus p squared minus p plus 7 equals to 0, which is not a quadratic equation. Now let's learn about discriminant. The discriminant of a quadratic equation ax squared plus bx plus c equals to 0, where a, b and c are some constants and x is a variable with highest degree 2, is given by d equals to b squared minus 4ac. Remember, d equals to b squared minus 4ac. Let's see an example to find the discriminant. Our equation is 2x squared minus 5x minus 6 equals to 0. So first of all, compare this to the standard form of a quadratic equation, ax squared plus bx plus c equals to 0. On comparing, we will get a equals to 2, b equals to negative 5 and c equals to negative 6. Now just plug in these values to equation d equals to b squared minus 4ac and you will reach 73. So 73 is the discriminant of equation 2x squared minus 5x minus 6 equals to 0. Now let's see another example, that is 2x squared plus 5x minus 9 equals to 0. You need to find the discriminant of this. Now let's compare this to a general equation ax squared plus bx plus c equals to 0. On comparing, we get a equals to 2, b equals to 5 and c equals to negative 9. Just plug in the value to d equals to b squared minus 4ac. On plugging the value, you will reach till 97. So that means 97 is the discriminant of 2x squared plus 5x minus 9 equals to 0. Now let's learn about roots of a quadratic equation. The very first point says roots of a quadratic equations are the values of the variable satisfying the equations. By satisfying the equations, I mean when you plug in the values, it should satisfy the condition that left hand side should become equals to right hand side. Now look at the second point. It says for every quadratic equations there are two roots. Remember, a quadratic equation always have two roots. Look at the third point, and it is a very important point. The two roots may or may not be equal. I repeat, may or may not be equal. Let's check whether negative 5 and negative 4 are the roots of the equation x squared minus 9x plus 20 equals to 0. All you have to do is just simply plug in x equals to negative 5 in the given quadratic equation. On plugging x equals to negative 5, we find x squared minus 9x plus 20 becomes 0. So that means left hand side equals to right hand side. So x equals to negative 5 is the root of the given equation. Now let's check with x equals to negative 4. On plugging x equals to negative 4, x squared minus 9x plus 20 gets equals to 0. So that means again left hand side equals to right hand side. So we can say x equals to negative 4 is also the root of the given quadratic equation. Now look at the second example. Check whether x equals to negative 2, 3 are roots of equation x squared minus x minus 6 equals to 0. Simply just plug in the value x equals to negative 2 and x equals to 3. On plugging x equals to negative 2, we reach till 0. That means left hand side equals to right hand side. Similarly, x equals to 3 will also give left hand side equals to right hand side. So that means x equals to negative 2 and 3 are roots of the quadratic equation x squared minus x minus 6 equals to 0. That's all for today. With this, we end the session. We are going to continue next time. Thank you, take care, and bye-bye.